160 years ago, a long time ago. My name is Janne Öhman. I'm the CEO of the regional company, Siemens Osakeyhtiö. I have been around Siemens and related businesses already for more than 20 years, mainly in Finland, but sometimes also looking at the other side of the coin from the headquarters point of view in Germany. And I'm really pleased that you are all here. We are pleased to host this OPC Day here at our premises, and we are really pleased to give you an outlook how Siemens is looking like today. What are we thinking about digitalization and Industry 4.0? But before going into the slides or presentation of mine, I would like to give you short outlook how Siemens is looking like today and what are our focus topics globally. William, I might need some help from you with the video. Short video in the beginning and then we can continue. Sounds good, but not looking good.
Enterprises must constantly. In rapidly changing global markets, enterprises must constantly innovate in order to satisfy customer needs and stay competitive. Therefore, we've built our position along the value chain of electrification. Together with our strong competencies in automation and digitalization, we help our customers increase efficiency and reduce time to market. Electrification is our foundation and our future. Looking ahead today, we're already installing the energy systems of tomorrow with products designed to generate, transmit, distribute, and use electrical energy as efficiently as possible. In automation too, we have been a global player for decades, with the intention to expand even further. And we make increasing use of the opportunities provided by digitalization to generate added value for our customers. Combining our engineering and data expertise, we create truly intelligent infrastructures, seamlessly connecting the physical and virtual worlds. We drive forward the future of manufacturing. We are leading the way in connecting hardware, software, and data across all domains. And we have the know-how for turning the big data generated by billions of devices into even bigger opportunities. That's why customers all over the world trust us, count on our technological excellence, and continue to look to us for real innovation. We set new standards, making real what matters.
No niin, vähän mahtipontinen, sorry, in English. It was an interesting video about Siemens, and I hope you got the understanding. One video tells more than 1,000 words, as you know. Coming back at the end of the presentation, what Siemens is in the brackets, but let's kick the presentation off now and to the topics of digitalization. What does it mean for us? What does it mean for most of us here in the audience as well? Then some words about Industry 4.0, from vision to reality. What kind of examples we can already see today, how Siemens sees this topic. This is not purely and only Siemens topic, as you know. Then some cornerstones of Industry 4.0, and I have a few examples also for you where we can already see the first signs of utilizing 4.0 type of environment. And some facts about Siemens at the end of the presentation. As you know, this is more than evolution. Some people are even calling it a revolution, and this is exactly what is going on and happening at the moment for us as individuals, consumers, but also for our businesses. Many things are changing, as you can see from the picture. Businesses are changing, the behavior of the consumers are changing from bookstores to e-books, and from yellow pages to marketplaces, from record store to streaming, and so on. Uber is not the least example which you can show in this kind of events. So many things are really happening, and I guess here in the room there are nobody who thinks that this is not affecting on our behavior as a human beings or individuals or into our businesses, daily business operations. Like Pekka Lundmark, the former CEO of Konecranes, today CEO of Fortum, used to say in his speeches and presentations, everything that can be digitalized will be digitalized, and this is pretty much true. The question is only who is going to make it happen, how it's going to be done, and when it will happen. But the fact is that it will happen, and therefore I think this is common denominator for all of us here in the room as well. So digitalization for Siemens, maybe you got some idea from the video, but what does it mean for us in the long run? I told you that we have been here around in the region in Finland already 160 years nowadays, and the company as such is almost 170 years old. So we have a long history, very long history, and we have our current businesses which are very roughly described on the top of the picture. So we are dealing with energy production, power distribution, industrial production, buildings, mobility, etc. And electrification is something which is a common denominator for all of our businesses. It has been there from the very beginning of our businesses, and it is still there, and it will be there also for the future. Key element. Then the next productivity improvement for our customers and the processes behind, we were able to give in the late 60s and 70s when the computers were introduced, because then we were able to offer automation for the processes we have been electrifying already in history. And it is very natural and obvious that the next step for increasing productivity for such processes where we have a long history will be and is already digitalization. So there are three elements in our businesses, all of our businesses nowadays: electrification, automation, and digitalization. But we are not just talking about the big data. Many people are talking about big data. Big data has no value at all if you don't have the understanding of the data, behavior of the data, and how can you utilize the data. And understanding is coming from the huge install base, in our case, of course, from the history, we have been doing many kind of businesses in all our industries, and there is huge install base existing for us globally. And we have domain know-how, we have device know-how, we can make the analysis, which is very crucial and important when talking about digitalization. And therefore we are not really talking about big data, but we are talking about the smart data. How to turn big data into the smart data. This is the name of the game for us, because if you have the smart data and you are able to make the data analysis, which are then creating business intelligence, and by having business intelligence you can create business innovations, and the innovations are creating values for our customers. And this is the name of the game. And when talking about digitalization, one can say that it's the technology, and there is the technology, of course, behind the digitalization and different kind of platforms. But most of all, it must be a new value for the customers, and new type of benefits. And the benefits can be, for example, better performance, cost savings, energy savings, risk avoidance in many sense, like in safety and security related issues. But it can also be totally new business ideas. How to make business and business models can be really renewed by having digital business model for your customers and of course for yourself. And this is why Siemens is very keen on building this digital platform for our customers and for our businesses, because we think that we have all that is needed for creating this extra value add and customer benefits. An example could be taken from our own businesses. As you may have seen from the video, we are dealing with the wind power businesses. We are actually number one worldwide in offshore wind, number two in traditional wind power businesses and turbines. And it's business which is run from Denmark, and we have a huge remote monitoring control center in Brande, Denmark. Around about 8,000 wind turbines are online connected there, and we are analyzing data every day. Daily, more than 200 gigabytes of data will be analyzed, and we are making calculations about the algorithms, more than 300 million a week. And the result is that more than 90% of all alarms which are coming out of the turbines can be solved remotely, so that nobody really needs to go on site. And you can imagine the benefits for our customers. They are producing energy, and of course, especially the offshore wind park, it's not so easy to go on site, and it also costs some money if somebody goes there and fix some problems. So if you can fix the problems more than 90% online without nobody going on site, it's a huge benefit. Just one example, and there are some more coming. As in the headline, Industry 4.0 is the topic most people are talking about nowadays. Again, it's about business benefits for our customers, which we should talk about. And if you have a solution which can influence on these KPIs, then you're on the right path. And of course, the Industry 4.0 is mainly affecting on these parameters of KPIs, like faster time to market, enhanced flexibility, more output, and increased productivity, meaning less costs, better operational excellence, etc. But these are the parameters where you must influence, otherwise nobody is willing to buy just the technology. But if you can influence on these, then the interest is of course raising. So increasing the productivity with the smart products first. The product can be smart. of course, everybody would be eager to hear stories from the automotive industry, even from the Volkswagen, how they are doing it. But I don't really have any insights on this automotive industry. Otherwise, it's very much known by us. But beer bottle can also be a smart product, having the information, for example, what type of beer it should include, what is the brand of the beer, because you know nowadays we are talking about the big producers of the beers in the brewery industry, and there are different brands of the beer. The content might be the same, but brand might still be different. Even though you think you might taste it, but sometimes it's not true. And the label might be different. The top of the bottle could be different. So this bottle can have all this information if it's a smart one. If it's a certain way of communicating with the system. And the system itself, of course, we are talking about machine-to-machine communication from the products to system and vice versa. And having this kind of system, you can be much better in reacting the market needs and behavior of the market and influencing on the production by having intelligent production. But for having intelligent production, you need to have intelligent products in the beginning. And this is where all digitalization is normally starting in manufacturing industries. Have some more examples coming later. But this is the typical value chain in manufacturing industries. First you have a product which you are planning, of course, and then you need to have production for manufacturing this product. This is clear. And then you have engineering, how you set up your manufacturing, how you steer it, how you control it, and then you start the production. And this is the border between nowadays a virtual and a real world. When you start producing, then something is starting to move and you get real products. Before that, everything is more or less on a drawing desk, or they are even digital. But then you shouldn't actually forget about the life cycle, because depending on the product, of course, you have various life cycles ahead of you. You may enter into the service cycles and other things, and you may even collect some quality-related feedback from the products throughout the life cycle to the very beginning of the value chain. And now, if you think about removing the barriers between these phases of your innovation and production process, then you can gain real benefits in many sense. But you need to be very digital in doing this. I mean, product, first of all, again, you need to have a product which you need to develop in 3D model, CAD systems. You might need to simulate it. It has to be 100% virtual to be able to be simulated. And then the product actually has all the information which is needed for not only for the product itself, but also for the production of this product. And integrating this phase is you can have the product influencing on the production planning of this product. And then if the production planning can be then simulated and made flexible enough to change the variants of the products automatically, etc., then you're already quite well on the way. But there is more to be integrated. I mean, the engineering, if you already have simulated everything, starting from the product, and the production itself is fully simulated, which is virtual models, then obviously you would need to have a lot of information which is already available from these phases to the engineering phase, because it is existing more or less. Of course, something you still need to do, but most of the information is available for you. And then you go from virtual to real world, start to produce, start to collect information in various ways, connect feedbacks to the innovation system, and it is actually kind of a circle, what we are talking about. At Siemens, we are talking about the digital twin, which is actually the digital product, 100% the same as the one which will be produced at the end of the day, but you can simulate everything by having a virtual model of your product. And production is actually the same thing. And this is very crucial. Many industries are already utilizing it. Maybe in the video you saw very shortly, Formula 1 car is just one example from the automotive industry in very extreme, where they are already utilizing most of the teams in Formula 1 Siemens PLM software to create parts, models of the car, 100% virtual, like a digital twin, simulating everything before it goes into the production, because you can't really spend time on testing the real product. So you have to test it in a virtual world, and it has to be really like a real. It's a huge benefit. You can by having this kind of integrated value chain, you can decrease your time to market by, let's say, 60% examples we have from, for example, automotive industry. Huge benefits for the customer. Then looking at the Industry 4.0 type of environment, we are not just talking about this type of digital value chain, but we are talking about the whole ecosystem, which is actually an autonomous production, reacting to internal and external data in a very good manner. Because, you know, markets and customer needs are changing rapidly online all the time. And the production must be able to adapt to external changes as autonomously as possible. And autonomous production needs relevant data in real time. So actually we are not talking about things which are happening inside of one factory, but we are talking about the whole ecosystem, including the consumers and market behaviors and suppliers. They are all interlinked, connected, online. This is how the things are looking in an Industry 4.0 world. It is actually, by the way, an initiative of German automotive industry, sponsored and supported in the beginning by the German government, boosting the German export industry, but it is becoming more and more like a European standard for increasing productivity in manufacturing industries, because there are, you know, several other type of ecosystems like Industry 4.0, one in the USA, the other one can be found from China, for example. So it is kind of a competition of ecosystems, because everybody needs to have increased productivity and digitalization. Few cornerstones of Industry 4.0. First of all, talking about digital twins, for example, you need to have smart products. This is the starting point. Then you need to have seamless integration of engineering of the entire value chain, as I was trying to explain to you. And you need to use highly intelligent models like digital twin, and you have to have a modular network, online connected and secure automation. Maybe the security is a key word here. So cyber security is the key here. If we are working in a very open environment, ecosystem of different vendors, companies, focusing on same plant or manufacturing facilities, it needs to be secured. So the cybersecurity is already an issue and will be even more for the future. transparent factories internally and externally, which needs to be networked between each other. At Siemens, we think that we are on a level of probably 3.8, if you may say so. PLM, MES, and totally integrated automation are part of our platform, which is called Digital Enterprise Software Suite. And the collaboration platform, which is actually a huge database having all the information throughout the value chain, is called Team Center in our case, connecting all these phases of software integration in your innovation process. But it's not really 4.0 yet. It's quite close, but we still have way to go to fulfill the requirements of the Industry 4.0. This is the factory in Germany where Simatic PLCs, for example, are produced. I think it's one of the most modern factory in the world, and this has been the role model for many of the Industry 4.0 examples. And it is using fully automated, highly automated processes, so that 75% of the whole factory is automated. There is no need for human being to touch any steps of the processes in 75% of the production. So only 25% of the production is something where you need human beings in this factory. And there are a lot of products, more than 1,000 product variants coming out of the factory every day. You can online change the product which you want to produce without human being. You need to touch any steps of the processes. And look at the quality improvement, what we have reached there. The production quality is 99.9988%. So this is a really good example of the quality if you really make everything digital and automated as much as you can. And of course, at the same time, when everything is digital, you can measure everything. So it's not only the production and productivity you want to improve, you also want to improve your, for example, energy consumption in a factory, and this has happened in this case. Shortly, time is running out. Next example is integrated engineering in Stora Enso's board mill and chemical pulp mill project in China, which is called Tiger as a project name. We'll be starting the board mill. Will start at 2016 and chemical pulp mill in 2018. But they're using their integrated engineering together with our Comos engineering platform and Simatic PCS7 DCS system. And there is a process electrification with various drives and motors and power distribution from Siemens in this project. Maybe during the breaks we can discuss more about this if you are interested. But let's take the next one. This is interesting. Seinäjoen ammattikorkeakoulu, Seinäjoki University of Applied Sciences has made Finland's, maybe the Europe's first digital twin demo together with us, and they are using actually OPC in this demo. So it is made, the machines, virtual machines are made with Siemens PLM software, so that you have 3D model of the machine, fully operational machine, and then you have a 1500 Simatic PLC plus HMI, and you can really control with PLC hardware virtual machine made by the Seinäjoki Applied Sciences University guys, students basically. And the interface between the TIA portal, our automation platform, and the PLM digital twin has been made by using OPC interface. And this is something unique, and these guys have collected several acknowledgments even recently. For example, Eläköön Automaatio prize in the Automation 2050 fair just a couple of weeks ago, and this is something which is motivating highly the students at Seinäjoki, because this is unique. They can really create something which is beneficial for the companies around the Seinäjoki area and even further away, and other universities are quite interested in going this kind of a digital factory world. Okay, shortly, Siemens, truly global company. The figures are 1 year old because we just started new fiscal beginning of October, and we are in silent period at the moment, so I can't really tell you the business figures from last fiscal year, so these are a little bit oldish figures, but roughly 72 billion euros globally the revenues, for 340 colleagues of us, and we are spending 4-5 billion euros in R&D, and we are active in 200 countries, and manufacturing facilities we have in all continents. Regional company Siemens Osakeyhtiö in Finland and the Baltics, we are roughly a bit more than 300 million euros in size, international revenues 500 million, and we have a little bit less than 600 people working for us. And these are the business divisions, as you can see in the picture nowadays in the Siemens portfolio. Nothing for the consumers anymore. It's just about energy production, distribution, smart grids, energy management, building technologies, mobility, and the industrial divisions. So we can be trusted partner for you, for our customers, from early concept discussions to complete solutions, and we are leading automation worldwide. Simatic is probably the best known brand for us, and we can support our customers throughout the entire life cycle. Thank you for your attention. Do you have any questions at this stage?
Any questions? Okay, no questions, then we thank Janne.